So get some notes out. Today's lesson is called Pythagorean Theorem Converse. So it's Friday's lesson reversed. All right. Ooh. Okay. Now I'm ready to teach this lesson. Okay, so let's get started. You titled your notes Pythagorean Theorem Converse. I am starting the lesson with a question. A triangle, cut it out. A triangle has side lengths 13, 85, and 84. So, I give you a triangle, here are its sides, and I ask you, is this a right triangle? Does it deserve a 90-degree angle marking or not? So when you're given three sides, how can you tell if they form a right triangle? What do you think? How do we tell? I gave you three side lengths. I said, is this a right triangle? This is a yes or no question. What do you think? Okay. So we brainstormed. How do we test if this is a Pythagorean theorem? If this is a right triangle, I just said the answer. We have to put it into the Pythagorean theorem. That is our test. That is the answer. Put those numbers into the theorem. It's either going to be equal or it's not going to be equal. So, put these numbers, here's your A and your B. I don't know yet. If A squared plus B squared equals C squared, then it is a right triangle. If they don't equal, then it's not a right triangle. What did you get? 13 squared plus 84 squared. 7,225. 85 squared. Oh my goodness. This is a really high number Pythagorean triple. It is a Pythagorean triple. It's whole numbers that fit Pythagorean theorem. Anyway, what we care about was that was a true statement. Okay, let's do this one. Is this a right triangle? Sure does look like a right triangle. Try it out. What are you testing? How do you decide? What are your steps? So we put it into Pythagorean theorem, right? Okay, so this is our test, like a litmus test in chemistry or something. A squared plus B squared, does it equal, question mark, does it equal C squared? And what numbers do we get? 2,560. Does that equal, was it 2,500? Yep. Okay. Obviously, no, we're 60 off. These do not equal. Alright, so when they don't equal, well then what kind of triangle is it if it's not a right triangle? Actually, it is a triangle. It is. I'm not going to get into the triangle inequality theorem from last semester, but it is a triangle. If we're naming it based off of its angles, it is not right. What are our choices? Okay, so if a triangle is not right, then it must be, of course, it must be acute or obtuse. So how are we going to decide which is which? First, I want you to write down the converse of the Pythagorean theorem. This is why I have my hat on backwards today, because we are doing converse. We are reversing the theorem today. So I want you to write it down, and I want you to pay attention to the fact that this was intentional. I purposely and specifically wrote C squared equals A squared plus B squared. And I purposely and specifically put my hat on backwards. So if C squared equals A squared plus B squared, then the triangle is a right triangle. But the whole reason we're doing today's lesson is, what if it's not? What if it's not? Then what happens? So let's use a trusted geometry software called Geometry Sketchpad to show us numerically what happens. So right now, angle A is 90 degrees. Notice C squared, oops, no. It must not, see, the problem is that we oversimplified this and we rounded things. There we go. So that 90 was probably like an 89.7. Anyways, it's rounded to make this simplified. Angle A is 90 degrees. Now C squared equals A squared plus B squared. What I'm going to do is move that vertex around, and I want you to draw some conclusions. I want you to pay attention to how C squared compares to A squared plus B squared. So, I'm going to move it right here. What kind of triangle do we have? acute, right? Because 85 is less than 90. How does t squared compare? Greater than, less than, equal to? Less than, right? Okay, so if I keep this acute, let's do another acute, and less than. Super acute, and whoa, super less than. Super acute, still super less than. Okay, let's try an obtuse. Obtuse angle, whoa, greater than. Let's do a different one. A really, really, really obtuse. Okay, obtuse angle, whoa, greater than. Obtuse angle, greater than. So what we can conclude is no matter where I drag that vertex, if c squared is greater than a squared plus b squared, it is an obtuse triangle. If c squared is less than a squared plus b squared, it is an acute triangle. So this is today's lesson on this slide right here. If they are equal, it's right. Less than acute, greater than obtuse. The reason I'm wearing this hat backwards is so that you remember every time to write Pythagorean theorem backwards. If you don't write it backwards, you'll get mixed up and you'll choose the wrong one, possibly. So, write it backwards every time. When you write it backwards, less than goes with acute and greater than goes with obtuse, which in our brains makes more sense. Write it backwards, picture Miss Stanton in the backwards hat, being silly, just so that you remember to write it backwards. Okay, we're going to try two examples. You don't really need to see any examples, but we'll do it just for fun. We're going to do 1 and 2, and then you need to begin your quiz. First thing, most important, identify your C. Identify your C. You know what? I'm not even going to do this one. I hope that you can see, maybe you've memorized this, that is one of the Pythagorean triples that we talked about. It's a Pythagorean triple. They're equal. I'm not going to do number 1. Let's move on. Let's do number 2. First, identify your C. Then set up your equation. 15.8 squared is, I don't know, greater than, less than, or equal to 10 squared plus 12.2 squared. So we go to our calculator. And we do 15.8 squared. And we write it down. 249.64. And then we do 10 squared plus 12.2 squared. I go ahead and I add them in my calculator. I don't need to write another step. Then remember, the inequality likes to eat the bigger number. Whichever number is bigger, that's what it faces. It's hungry. So it eats the bigger number. That is a greater than sign. That is a greater than sign. We read from left to right. That's a greater than sign. C squared is the winner. C squared is greater than, so it is obtuse. Let's try the next one. Here's our C. C squared is, I don't know, compared to A squared plus B squared. 9 compared to 4 plus 4, 8. The inequality eats the larger number. This is our winner, winner, winner. C squared is greater than, so we had 2 obtuses in a row. The rest of them you can try on your homework for more practice. Cool. You may begin your quiz.